So we'll start today the method of distribution function. But this is something you already have done in probability. At least I'm hoping that you already have done in probability. And that is your chapter 5. So this is your reading assignment because you are already did this in probability. I'm not going to cover this again. So your reading assignment is chapter 5. And start from 5.2. And again, this is you should cover in probability. So those are the definitions of distribution function. Go through the example. There's the discrete case, and then go through the continuous case, how to figure that out, how to find the probability and the distribution function there, all the examples. And if you want to try some exercise problems, you can do that too. I'm actually more concerned about chapter 6. But the example that I'm going to use in chapter 6 is actually related to example 5.4. So this is your must-read assignment, example 5.4. If you never encountered this type of problem, you should go through example 5.4 to figure out what's going on. But that's not the problem we are going to do. We are going to do a chapter 6 example which is connected to example 5.4. So read chapter 5, especially 5.2. Try to do some exercise problems. Read example 5.4. But I'm giving you an in general example of what is a distribution function, how to find it. For example, there's a continuous density. Small f of y is 2y, and y is between 0 and 1. I'm defining u as a random variable, which is 3y minus 1. So the question is, what would be the distribution function of u? So I'm trying to figure out what is the distribution function of u and what is the density function of u. That's my question. So to figure that out, we are using the definition of a distribution function, which you should know from the probability, which is probability capital U less than equal to small u. And I'm replacing this capital U by 3y minus 1, since that is the relationship between u and y. And I'm changing this to capital Y less than equal to u plus 1 divided by 3. So this means that we are integrating on the variable y from 0. Why this is 0? Because this lower limit here is 0. To u plus 1 over 3, 2y dy. And if I do that correctly, that should be u plus 1 over 3 square. So that would be the distribution function of u plus 1 over 3 square. Now, one thing is important to figure out, what is the range of u here? So what is the range of the distribution function here? And that should follow from this range. So what's the connection here? If I plug in 0 here, then u goes up to 2. If I plug in 1 here, if I plug in 0 here, u goes from minus 1. And if I plug in 1 here, u goes up to 2. So this value is valid between minus 1 and 2. So that would be your answer for distribution function. Now I'm rewriting the distribution function here. So how to find the density function? That will be the derivative with respect to u of this, which is, if I do that correctly, should be this. So that is what we are looking for. Now I'm giving you the next example, but you should read this after reading example 5.4 of page 230. After this, after reading this is the example that you should be able to understand. But there's a different question I'm asking. This is a joint distribution of y1 and y2, and that's given as 3y1, 0 less than or equal to y2 less than or equal to y1 less than or equal to 1. I'm defining a random variable u as y1 minus y2, which actually implies y2 is y1 minus u. Now, here is a little graph I'm drawing here, which will make more sense if you understand example 5.4. So this is between 0 and 1, what's happening. So I'm drawing this right angle triangle, which is y1 minus y2 equal to u. And this is an arbitrary u I'm drawing, which is this point right here is u. And what I'm asking here to find the distribution function of u, which is this. So essentially this is the area that we are trying to figure out what is this area would be. And how to do that? It's better to write this 1 minus probability of u greater than u. Now I can integrate this because this part is this part. So 1 minus from where to where we integrate? From u to 1, the outer integral, which is this, u to 1. And the inner integral will be from 0 to y1 minus u, which is 0, something like this. And then the PDF is 3y1 dy2 dy1. And then if you do the integration here, 1 minus u to 1, I'm taking the 3y1 out. And from this one will be y2 from 0 to y1 minus u dy1. So I'm doing this integration first. And then that will be 1 minus u to 1 3y1 times y1 minus u dy1. And you to do the integration, 1 minus, this will be 3, then u to 1 is y1 square minus u y1 dy1, and we do that, do all that. Finally what we come up with, I'm skipping some steps here, but if you do that correctly, it should be something like this, which is if I take 1/2 outside, then 3u minus u cubed. That would be the distribution function. This will be this one. Also, what's the range? The range of u will be between 0 and 1. What would be the density function? That would be of 1/2 of this, which is 1/2 that's the density function. Now I can add these questions. What is the expectation of u? Which will be between 0 and 1, u times 1/2 3 minus 3u squared du. And you can do the integration here. It's a pretty easy integration. If you do that correctly, you will get 3/8. And similarly, you can find expectation of u square, and you can find variance of u. So this is I can ask the context of this example. But that's the idea. That's the part that what we are doing now. It's a little bit different than 5.4 example. So example 5.4, first read that. And if that makes sense, then try to integrate this, try to find the distribution function of this y1 minus y2. That's what we are doing here. I'm gonna discuss some properties and I'll give you more examples on this next time. So your main task here then, reading chapter 5, because that's in the probability that I'm kind of expecting you already remember. And also reading example 5.4 because this is connected. So kind of a reading assignment, that's more important here, the reading assignment part, and then understanding the distribution function concept, why we are doing this. Our main target is finding the density function. All right, this is distribution function part 1. I'm going to post part 2 soon.